Ben All right. Hello there. Aisha, can you hear me?
I sure can. Can you hear me and see me?
Perfect. Sorry for the delay. It took a little longer than we anticipated to come back from lunch, and our setup is delayed a few minutes. But we are almost ready. So, unfortunately, there is no camera to show you the crew, but we have 90% of our hackathon crew here. There is only one team from Kenya, which got the passports yesterday in the afternoon. They are flying tonight. But the rest of the hackathon crew from Tunisia, Algeria, Cameroon, Namibia, and Ethiopia, also some Kenyans, they are already here. So, team, it's my pleasure to introduce you, Miss Aisha Walcott Bryant. We had a chance to meet a few weeks ago. She is the head of Google Research in
Oh,
Kenya.
amazing. So
And Aisha, it was a real pleasure to meet you. Like seeing somebody like you who is overachiever, who is from Africa, who is in the
I'm
field of
trying to see
AI.
my internet.
Like personally,
Let me see. Let me see if I can.
let me see if I. Looks like there is a connection problem from our side as well. I guess. Are you sure? All right. How about now, Aisha? Can you hear me? There's an connection problem from her side. All right. So we can see your screen, but we don't hear you at the moment. Yes. Aisha. Remember.
Hi, can you guys hear me?
Hear me? Yes.
Okay. The internet is not great,
The internet is not
but
great, but
but I
are
hope
you
we
in
can
Africa
make
or
it
what?
for 25 minutes.
25 minutes. No worries, Aisha. We are very familiar with the connection problems. So I'm not going to get more time. Our audience is ready to get inspired by you, Aisha, and the stage is yours. Thanks for being with us. We can get started whenever you are ready, Aisha.
Okay. Okay. If the connection is too bad, I can also call in by phone. So let me actually
Right
do
now it
that
is
so
work.
that you can at least hear me clearly.
It seems to be working at the moment. If you want, we can give it a try. If we break up, we are going to let you know.
Can, okay. Okay. All right. So just small delay. Hi, everyone. I had the pleasure of meeting Emre a couple weeks ago. And I wanted to take the opportunity that he reached out to meet all of you all more to talk about a little bit of the types of projects we are working on, or not just we, because it's across multiple organizations I've been in, but to talk about, also talk about like career and thinking about the growth and the potential of being in Africa, especially as a data scientist or an expert in AI or even just technology in general. So let me start my slides. Great. So we are betting on Africa. As many of you all know, have a projected population growth almost double by 2050 of up to 3 billion people, and 1 in 4 persons on the planet will be from Africa. Our continent is rich and diverse with more than 2,000 languages, 3,000 ethnic groups, and what I find most exciting is that our global youth, 40% of the global youth will be in Africa by the end of this decade. I mean, that's incredible in terms of ideas, energy, potential, students, workforce, everything. So I'm based in Nairobi, Kenya. I lead up our Kenya Research Lab, a part of the Google Research Africa team. Kenya is known as the Silicon Savannah. There's quite a number of big tech that is investing in Kenya. I actually came. I actually came when limitations in compute, models, and so forth. So, with that question from the domain experts, we set out to frame the problem as a reinforcement learning problem. And the reason is this. In the disease modeling world, there's been quite significant efforts over many decades to model a number of diseases, including malaria. So you have a lot of communities that are modeling the potential spread of the disease based on types of interventions to potentially limit the disease in other types of scenarios. When you think about a disease model and putting in inputs and receiving outputs, maybe it's the number of people who are affected by malaria, this is actually a simulation environment. So now you have a simulation environment where you can do a set of actions, in our case, we call actions interventions, and run the simulation and see projected outcomes of malaria disease incidence for a certain region. At the top is this white image. In there, you can barely see the writing, but this is basically a pictorial graphical example of a malaria intervention model, starting with the mosquito, potentially infecting a human, infecting a cow that you see at the top. It's got blood. You can see humans under a net, and then you can see a body of water at the bottom where they might lay their eggs and so forth. In blue, which you can't read, but that's okay, blue are points of intervention. Blue are points where policy and decision makers can potentially, provide budgets, supplies, resources to limit the spread of malaria. And this could be larvicide in water bodies, it can be bed nets handing out to communities, and so forth. So this creates if-then scenarios. If we give out, hundreds and thousands of bed nets, then what will be the incidence of malaria? Those are the kinds of questions you want to ask in a simulation environment. So our aim was to build AI agents, and we have a genetic programming one. We have one that follows like a Monte Carlo tree-based search, any types of algorithms where you're exploring a complex combinatorial space where each node in the space is essentially your set of actions. How many bed nets are you going to provide? How much spraying are you going to do on the homes for a specific region? Then you try it, you run the simulation, you get a projected output. This reduces the prevalence of malaria by 20% in this region. And then the policymaker needs to decide, is that good enough based on the budget? So this is one example, and you can take note of the papers and the link below of where AI is actually being used in a novel way to answer domain expert questions on, are there other interventions that policymakers can use? And the answer was yes, to apply different types of strategies, interventions to control malaria. This work was also featured in a challenge at ICLR, where we had more than, I think it's 200 teams and 700 submissions. So the beauty was we brought a first of a kind global health problem to the AI community, and there was great excitement to apply all sorts of AI agents and algorithms in this framework to explore a potential solution to a problem that is facing many of us across the continent. So that's just one example. I want to make sure you guys can hear me okay?
Yeah, we can hear you.
Thank you. That's one example. The next example I'll do is forecasting floods. And again, there's a link to the site we have called Flood Hub, where we are forecasting floods up to 7 days in over 80 countries worldwide, using AI methods for hydrologic and inundation models of riverine flooding. So if you go to that site, it'll show the different levels of potential flooding in the countries that we cover, including 23 countries in Africa. So in the flood forecasting work, this started with a very small idea, just like one engineer thinking, can we improve maybe the age-old common methods for modeling water, hydrologic models, and the extent of water as it goes through rivers. And can we use AI to do that? And in this case, LSTMs, which are using a temporal-based method, were used to improve the predictions of floods, where forecasting not only the level, but also the extent. How broad are they going to be impacting a community? The beauty of this work, as well as the previous work, is it came from working in the communities that are affected by these challenges. It came by working with a small community, I believe in India, where when our team went there, they discussed, how do you do your alerts when there are floods? This is a flood-prone area. They basically just pointed to their knee. When the flood gets to the knee, then they alert the community that they should evacuate their homes. That simple conversation led us to build the inundation model because it showed that we needed additional information in addition to a hydrologic model in order to provide the right type of warnings for communities. Since then, we've grown a team over a few years to build out this effort, improve the models, and then there's a huge part around how to make the outputs of these forecasts relevant and useful to the communities that are impacted. And this is through partnerships with a number of agencies and governments across the globe. You can see some of the technical work in the two papers below, and you can see the details on this overall project at the link on the right. And lastly is the work that I've started just recently as I joined Google 1 year ago. This is around addressing food insecurity in Africa. When I started in this work, I didn't know anything about food insecurity. I'll tell you a bit more about my background, but I had not been working in the agriculture or food security space at all. And so it shows you the research journey of starting a new project as well. For me, I sit in the Horn of Africa in Kenya, and the Horn of Africa for the past few years has been struck by unprecedented levels of fatalities and populations, especially vulnerable populations like children under 5, who are severely food insecure. If you look at the graph on the left, it shows that from 2014 to 2021, for the main regions around the world, it shows that we have generally increased in severe food insecurity. And severe food insecurity means you and your family have gone maybe days or so without food, and you don't know where your next meal comes from. So this is, obviously not a planned circumstance, and you're not sure if you're ever going to get food again. And what's terrible about it is while it's increasing year on year everywhere in the world, Africa shares the largest burden. And if you remember, we also have the largest growing population. So if we are struggling to feed our population now, imagine what it will be like in the next coming decades. This, in my opinion, is an absolutely fundamental challenge that we need to focus on in the AI community to bring AI, data science, data enabled tools to build and transform food systems across Africa. Also, when I started on this project, or slightly before, there was an article of a woman in East Africa who had lost a child due to hunger. This is in 2022. And then later, as you read down in the article, she is taking her kids to where food is dropped off and distributed, and another one of her children perished along the way. I was thinking, it's 2022. How can a mother lose multiple children due to hunger in East Africa? And I also read an article that Tanzania had a surplus of food. So this is our region. It shows you that the problem is complex. There's infrastructure, policy, data, and many other challenges. And the way we are looking at it is really around forecasting food insecurity to know and prepare for potential populations that might be impacted. So that's on the food insecurity side. Now, you can think of that as the demand side, the people or demand or crisis side, people who are in desperate need of food. And then we need to think about the supply side. The supply side is thinking about agricultural production as an example. In this case, we are looking at a graph on the left that shows the increase in the production of cereals, a kind of a major commodity, from 1965 to 2020. The good news is pretty much it has grown in all the regions. And also, again, the unfortunate news is the pace of the growth in Africa is slower than everywhere in the world. Again, imagine in these next coming decades, 1 in 4 persons are going to be from Africa. We're going to need to optimize and be efficient about our agricultural production, given climate change, economy, and other drivers that impact the supply. On the right is a graph that shows the demand. In sub-Saharan Africa at the very top, it shows that the demand is far higher than most other regions in the world. And so you can see this clear gap between the two graphs, left and right. So our new work is building AI tools to transform Africa's food systems. Specifically, we are working with partners to support smallholder farmers for increased production. In Africa, we have over 700 million smallholder farmers, roughly that number, and even if we're off by 100 million, it's a lot of farmers. And as I mentioned, we in East Africa had 5 to 6 seasons of drought that created unprecedented food insecurity in the region. So we need to adapt and think of ways in which we can change our agricultural practice to adjust to climate change. In this case, it was multiple seasons of drought. So we're building tools for the developer ecosystem to enable them to be able to reach smallholder farmer networks. And then on the right, back to our food insecurity problem, is us exploring machine learning time series-based models to predict where people are who are vulnerable to food insecurity, who are at risk, with enough timeline that allows, ideally allows agencies to respond with something more than, hey, we need a plane to just drop rice, to also consider the nutrition component for those who are severely food insecure. So those are 3 examples, concrete real-world examples where you have teams in Africa, on my team, and even at other organizations that are building and leveraging their machine learning expertise to address problems on the continent that many of us know and are faced with. And these problems, most of them are global. There's not just in Africa in which these are challenges. So our belief is what we build in Africa, because of our richness, a diversity of the continent, these solutions can scale to other parts of the world. So I just wanted to do those highlights. I didn't get into technical detail. I hope the references will excite you there. But I also want to spend a minute talking about my career side so that maybe it will help you think about what you want to do in your career and what is possible. So everyone can hear me okay so far?
Yes, Dr. Aisha.
Okay, let me pull one kind of overview slide here. Yeah. Okay. Sure. Okay, great. So with that said, those were just a couple of projects that we are working on now. I want to kind of talk a little bit about how I got to Kenya, how I got to Nairobi. So I actually was born and raised in Maryland in the USA. I did my undergraduate at Clark Atlanta University, which is a historically Black college or university based in Atlanta, Georgia. I did it in computer science, and growing up, I was always into, let's say, electronics and breaking electronics open mainly to see what was inside and to recreate. And that was just my nature. I didn't like, it's not because I'm female or not female. It's just I was into it naturally. And then to kind of continue my education and also my desire to explore more about, let's call it cyber physical systems, I went to MIT to pursue a master's and a PhD in robotics at the Computer Science and Artificial Intelligence Lab. So in my master's, I worked on multi-robot planning and exploration for scenarios like search and rescue, even planetary exploration. And what I realized, even doing those complex planning problems for these heterogeneous teams of robots, underneath it, you need to be able to do things like localize and map your environment over time. So then I did my PhD on what they call SLAM, simultaneous localization and mapping. And that's basically how do we put robots in an unknown environment and allow them to explore and represent the environment as it changes over time. While I was at MIT, I had the opportunity to work on 3 projects in Africa. And that's really what set the seed to me being here today. So the first was at the University of Ghana, Legon, where I was teaching computer science and entrepreneurship to a range of folks in Ghana from age 14 to age 60, some who came to learn Microsoft Word and left as computer programmers. So I just knew, like, given that small, tiny example in context, like, we have this incredible wealth of brilliant minds on the continent that can do anything. I also was a part of the team that deployed the very first Fab Lab that was in Sekondi Takoradi in Ghana. It was me and 2 other women and 32 boxes going through customs at the airport in Ghana. And these boxes had laser cutters, desktop mini mills, electronic circuits. So essentially a Fab Lab is a digital fabrication lab, like a makerspace. And we set up the very first one in Africa, and that was in Ghana. So those were 2 projects. And then after a bit more roboting on the PhD, my hunger to come back to Africa was ignited, and I had the opportunity to come to central Kenya to work on tools around educational technology like Edubuntu, IT awareness within schools in Kenya. From there, I was just going to look for any research institution, corporate research institution that was willing to invest in Africa. But that didn't happen when I graduated. Instead, I still wanted to, continue to be exploring the world. I worked in Spain for 2 years mainly on recommender systems and journey planning. And then eventually my internship mentor from my PhD, he was from IBM Research in New York, changed his LinkedIn status to Director of IBM Research Africa. I sent a small note, and honestly, the rest was history. I didn't think twice. I had just had my daughter in Spain, and my husband was there, who was also a PhD from MIT. And we all went straight to Kenya, where IBM Research was the first corporate research lab to open up in Africa. And they also had a sister lab in Johannesburg. So I worked there for 9 years on projects in AI for global health. So malaria control, like you saw, COVID-19 control. We've got some nice work that's also open sourced and in nature. Maternal newborn child health, understanding the impact of disproportionately affected women and children when it comes to maternal health and child health. Family planning, using sequence mining to understand contraceptive use, which I think is amazing. because sequence mining came out of like retail AI methods, and it can be used in such a cool way, important to our domain. I worked on transportation and mobility with Nairobi City Core and using the inertial sensors and unpacking the roadway conditions and driver behavior after we installed those mobile phones into garbage trucks that were driving around Nairobi. And I also worked on water security and water access in our arid and semi-arid counties. And now, as you know, as I mentioned, working on food security at now Google Research Africa. So I just wanted to lay that there to kind of give you a flavor of, the path that you go on. I never expected that I would be here, but once I came, I knew that it wouldn't be anywhere else. And I'm glad to be here and raising my family here as well. So that's it for me. Thank you. Any questions?
Thank you so much, Dr. Aisha. Yes, let's accept some questions from the team that we have here on the ground. So, team, do we have any questions for Dr. Aisha? Dr. Aisha has mentioned a lot of good points today. So, if you guys have any questions that's puzzling you, please feel free to bring it to the table so we can discuss about it. So, yeah, I have in the meantime, I have one question for you, Dr. Aisha. So, am I audible?
Are you able to hear me?
Are you able to hear me? Yes, you can hear me too as well, right? Dr. Aisha, am I audible? Not sure if it's internet connection issues. Dr. Aisha, can you hear me? Well, Dr. Aisha, I think we can hear you perfectly. I'm not sure if I am audible to your side. Yes. Okay. So yeah, in the meantime, I have one question for you. So yes, here in the Generative AI for Africa Hackathon, we have.
Yes, I can.
Okay. Okay. So yeah, in this Generative AI for Africa Hackathon that we hosted at I2SV, there are different categories in which the hackathon participants were involved in. Some of them being healthcare, and some of them
being. Yes, I hear you.
Okay. I'm not sure if the delay is because of internet issues from my side or yours, but if I'm still audible for you,
I don't hear the question though.
Okay, I think there is a huge delay, right?
I'm going to dial in.
Okay.
Dial in. Hello. Can you guys hear me?
Yes, Dr. Aisha, we can hear you. Can you hear us?
Hopefully much better. Yeah, so there was a question?
Yes, there was a question from me personally. So, in this hackathon that we hosted in the Generative AI for Africa hackathon, there are like multiple categories in which our hackathon participants were involved in. Some of them being healthcare, some of them being agriculture. So, so my question is like, what awaits these students after this point? So they have developed their projects using generative AI. They've been assigned mentors and they've got different sessions from multiple experts. So now they've pushed this far, and now they've become the finalists. And what awaits them now? How can they take it to the next step in order to make an impact the way you did to Africa? So what should they be focusing on? So this is a question I'm asking on behalf of all the participants.
Okay, great. No, really great question, and congratulations to everyone on the incredible domains that you focused on and learning and exploring with generative AI. I think first and foremost is an element of you being able to make sure you understand what you did. I know that a lot of machine learning is so-called commoditized, meaning we can build with blocks and so forth. But if you want to pursue a career in AI, machine learning, and push the frontier, it's good to unpack what's in those, let's say, any of those kind of Python libraries that you might be using, or whatever's in those blocks. Even if you just take one type of model and just understand the math behind it. The reason I say that is, there is an air of people feeling, the broader public, like, these are black box or magic methods. But really, there's math. And, it might be a lot of math because deep neural nets can be quite complex. But there is a core thing that, most of you all know and understand, and start there from the fundamentals and understand it. And that'll help you get the intuition to think about, wow, why did they build the model or the architecture in this way? And then you can start to understand the intuition underneath it. So I think one part is, take your time as students. It's a wonderful time to be a student, to unpack what you are developing beyond just looking at benchmarks and 90% accuracy. The next is on the benchmarking and accuracy and performance metrics. One, how do you think about the relevance and the usefulness? So I remember we were building, let's say, like a pothole detection algorithm. What's the difference between detecting potholes with 82% accuracy and 87% accuracy? From a business decision, it might be nothing, right? There might be no incentive to do that. So racing to just increase percentage points, I think now people are trying to, move beyond that from an accuracy perspective, to also fully exploring the model and what it means on the interpretability side, on the ethical side, understanding bias in the model. If I only have potholes from, from the countryside where there's dirt roads, well, it's not as representative of potholes that are from Nairobi in the city where there's tarmac and maybe they're, flooded with water, right? And then on the healthcare side, if I only have data sets from a certain population, just knowing and understanding and being transparent about that is important when you report your findings as a data scientist, machine learning expert, AI engineer. So you'll never have a perfect, equally balanced data set that represents the full world population. I think that is okay. I think the critical part is to be transparent that this is what the biases look like in the data, and that requires more analysis and more understanding of the potential communities of what you develop. So really, I'm just asking you to think more about the algorithms that you're developing, especially as students, especially when it comes to wanting to deliver this for impact from a business perspective. What does your accuracy metrics mean? What does precision recall mean when it comes to perhaps business or clinical decision making? And what does it mean based on the data that you're using? So I think those are two things to consider about what's next. But broadly, the world is next. It's completely up to you. We know the global youth are in Africa. So many big techs are investing in this region. I see the big techs as enablers, and that you guys have the bright minds for the next future startups that grow into, continent-wide impactful businesses. Thank you. Other questions?
Yes, thank you so much, Dr. Aisha. So do we have any questions from the crowd? So we have some new people who joined us. I'd like to say hi. Hi, team from Australia. Okay. So yes, one more question from my side, Dr. Aisha. So again, it's going to be centered towards the Generative AI for Africa Hackathon participants. So starting from Saturday and then this coming Monday, they will have a chance to showcase their works to donors and potential investors. So yeah, how do you think they should tackle this? Because they will have visibility across people who can potentially help them grow their projects and create visibility to them internationally. So how do you think they should handle this situation within the coming days?
I think number one, you should prepare. So I'm an advocate of preparing, especially when you have these unique opportunities where you can speak about your work outside. Understand the parameters, like is it a 2-minute pitch, a 5-minute pitch, a long presentation? And you need to be direct and upfront with what exactly is the problem you're solving, and what as scientists and as engineers, what are the limitations of your method? So don't, say like, this can solve X, because there's going to be a downside to it. I think be honest and truthful about the new ideas that you're creating. But yeah, I would say prepare, help each other prepare, help each other do pitches. The people in the room with you are going to be your network, probably for many years, maybe decades to come. Some of them might grow into policy roles. Others might grow into, new areas that can leverage AI. But this is a great network of peers, support each other and help each other through this. I think that's like the main thing about the opportunity. Also remember that generative AI is not just LLMs. So when I talked about a simulation environment for disease models, those are generative models. They're forecasting potential future scenarios based on inputs that, it's based on probability. So just know and understand that you can do more with generative AI. That's it.
Thank you so much for your insights, Dr. Aisha. So yeah, that's it from my side. Again, I would like to invite people, if attending here physically, to direct some questions that you guys might have to Dr. Aisha. So again, if there are any questions, please feel free to write to me as well. If not, I guess this is pretty much it. Thank you so much for your insights, Dr. Aisha.
Thank you all, and great work. I'm proud of you all. You guys inspire me, trust me. So keep going. Bye.
All right, goodbye.